All right, so replace f of x with y. Then what do we do? Interchange x and y. If it's a fraction, what do we do? Cross multiply. So 2 will equal x times 3 plus y. Let's get rid of the parentheses. What are we trying to solve for? Yeah, trying to solve for y. So, does everyone agree we'll have 2 minus 3x equals xy? And then what do I have to do to solve for? Yeah, divide by x. Is this what you guys got? 2 minus 3x all over x. Anybody else get that? So let's see. We replace f of x with y, interchange x and y, cross multiply to get rid of the fractions, distribute through, and then we're trying to solve for y. How do we do? We do okay? All right. Now what I want you to do is I want you to think about the domain and range of the original function. Right now, what x do we have to be worried about? What x do we? Negative 3, right? So the domain of my f, I'll write it in set notation, are all x's such that x cannot be negative 3. That okay? Now go ahead and pull a graph of that up. Go ahead and graph that. Is there a y that doesn't exist? Do we have an asymptote? Is there a break not only up and down, but is there a break like vertically for those branches? What is my horizontal asymptote? I mean, if you look at it visually, you'll see it. With our shortcut method, you should also see it. What's the horizontal asymptote? What is it? Oh, no, now look, Chris, you're on the right track, but look, the degree upstairs is not equal to the degree of x downstairs. Do you see that? There isn't an x upstairs. So technically, if we have no x upstairs and 1 x downstairs, what can you tell me about the horizontal asymptote? There is one, it exists, but we said it's y equals 0, yeah. Okay, so that means, graphically, do you see that your graph can never equal 0 for the y value? Did you graph it, Jake? Can I just get your calculator show? So let's look at that. A couple people had questions. They sent me the Ask My Instructor for Help button. Do you see there's a break here? Okay, let's do it in Zoom 4. There's a break vertically, but do you see this levels out and it's not touching that? Remember, it's that runway that our graph gets really, really close to but never touches. So there's a restriction on the range as well. It's just y can never equal 0. We okay? Now, what did we say about the domains or ranges of a function and its inverse? What is the domain? Now, the range says everything but 0. So what's the domain automatically of my inverse function? Everything but 0, right? All right, so then we'll look at it and see if that's true. So let's look at the inverse. Is that true? Is 0 something I have to be worried about? Yeah. Will 0 make the denominator 0? Oh yeah. So that makes sense, right? That makes sense. Okay, now let's think about the range. Right now, we automatically know what it is, right? Because we're going to swap the restriction. So since the domain of my function is everything but negative 3, that's what the range of my, oops, it should be negative 3. So, oh yeah, absolutely. So interval notation would be from negative infinity to negative 3, and then negative 3 to infinity. And this would be negative infinity to 0, and then 0 to infinity. That makes sense?
Oh, so we can write it like that.
You can write it either way. Yep. Okay, now, does this make sense? Does this have a horizontal asymptote at negative 3 that I can't touch, I can't cross? Now look, The degrees are the same upstairs as they are downstairs. Do you see that? What happens if we take the coefficients and make a fraction out of it? What do we get? Negative 3 over 1. So do you see how to do these now? Does that make sense, Diana? Yeah. Once you find the domain and range of your original function, that's a head start on how to find the domain and range of your inverse. They're just swapped. Jonathan, do you see that? Does that make sense? Was it you that sent me a question on it?
Yeah.
Does that make sense?
Yep.
Yeah? For sure? Okay.
Yeah.
Okay, good. So try it. I think there was just one or two in the My Math Lab that asked you to find it and then find the domain and range. Is that right, Diana? I think that there weren't that many. I only picked like 2, I think. Okay. So try them. Send me a question if you have a question on it. All right. So I want you to read this scenario. And let's understand what this kid is offering us. Okay, so this is the day, and this is the amount we have to pay him. Okay, so our neighbor's son comes over and says, you know what? I'm going to start right today, and I will work as hard as you want me to work for 10 hours straight. And all you have to do is pay me 2 cents. That's all you have to pay me. Yeah. Okay?
2 cents?
That's all you have to do. So July 1st, 2 cents. Okay. Now on July 2nd, he says, okay, all I want you to do is just double the previous payment. So how much would we pay him on July 2nd for 10 hours of hard labor? 4 cents. So we're thinking, well, this doesn't sound like too bad of a deal. So let's see what we would pay him for the week. So on the 3rd day of July, what would we do? 8 cents. And he is even willing to work the 4th of July. And we'd have to pay him for what? For that day? 16 cents. Not a bad deal. The 5th day, we'd have to pay him 32 cents. And the 6th day, 64. The 7th day of July, 128. So $1.28. Yeah.
Couldn't you just raise 2 to the power of number of days?
Yeah, that's what we're hitting at. We're leading into what's called an exponential function. Now this is very different than a linear function, right? Linear function has this constant rate of change. And when we talk about a constant rate of change, that's our slope. So this is definitely a different kind of concept. So we're thinking this isn't such a bad deal, right? Now let's talk about what Jonathan just said, and let's just see how much we'd have to pay him like on the 14th day, or on the, how many days are in July? 30 days have September, April, June, 31. On the 31st of July, how much we'd have to pay him. All right, so let's understand what an exponential function is. Now it's something that's not linear. The rate of change is not a constant. So what are we technically doing each time? We're doubling it. We're multiplying it by 2. All right, so I'm going to give you the function and then we'll look at it. Now this is what the function is. Now let's just see if it makes sense. And then we'll talk about how you can derive these functions on your own. So if x equals 1, do we get 2 out?
Yep.
If x equals 2, do we get 4 out?
Yep.
Let's try it. If x equals 7, sorry Jake, I stole your calculator. Do we get a 128 out? Yeah, okay. So this isn't a bad deal. We can usually figure it out. Hopefully we will do this before we hire him. So let's figure out the day before the last day we hire him. Now we've hired, so we are in it to win it. How much are we going to be paying him? Holy moly, right? Oh my God. We hopefully will have figured this out. He is a sneaky person, isn't he? Now keep in mind, that's in pennies. but it's still really big, right? So what is it? It's 1, 2, 3. So we would owe him for that day of work 10 million. I'll put it in dollars. $737, 418 and some change, 24 cents. That's in dollars, not in pennies.
Because you divide by 100.
Yeah, I just said, okay, these are all in pennies, I didn't want you to think we were going to owe him $1 billion, because that would just be crazy. This is only 10 million, right? All right. Now, I know automatically I don't have to do the next thing on my calculator, because what would we do for the next day? We're just doubling it, right? So this is a very sneaky math person. I'll just put the 31 in there, and you can see that that's what that would be doubled. So this is the concept of exponential growth. They're one of my favorite functions. I just think they're really cool because they start out so slow and then bam, they get really, really big really fast. Now, exponential growth is our friend if we are making an investment. Exponential growth right now for probably a lot of you is your enemy because you have student loans, right? And unfortunately, they will often compound your interest rates in this exponential way. If you've ever had fruit flies in your house, you know what I'm talking about, those little Drosophila thing, you know what I'm talking about? You know, you have like, oh look, there's a couple, and then the next day if you leave like a nasty banana out, holy moly, right? There's just tons of them in there, and they reproduce exponentially. As long as there's a food source, they will reproduce at an exponential rate. So that's why you get so many so fast. So let's just talk about the ins and outs of an exponential and compare it to linear. So we have these nice data values already that we just did. Oops. So let's look at it versus the linear. All right, isn't this just a nice linear expression, 2 times x? So we'll pick the same x values. And we'll compare the two. So if it's linear, 1 times 2 is 2. 2 times 2 is 4. 3 times 2 is 6, right? We're just adding 2 each time, right? We're just adding a constant each time. So for linear, you're adding a constant. Adding 2. And that constant you're adding is your slope. And that brings all sorts of memories back from 12, 15. Now exponential is totally different. What did we say we're doing? We're multiplying by a constant, right? Chris, okay. So for exponential, we're multiplying by a constant. To generate this table of values. And that constant we're going to look at later is what's called a factor, either a decay factor or a growth factor. So that's the big difference between linear and exponential. Linear you add, exponential you multiply. We doing okay so far? Alright, so once you're done with that, I want you to look at those 3 examples of functions, they're all functions, and say which one is linear, which one is exponential, and which one would be neither. If there is a neither, I'm not sure I haven't done these yet. Oh yeah, there is a neither. So what can you tell me about the first one? Are we adding a constant? Or are we multiplying by a constant to generate that table of values?
We're adding
We're adding. What are we adding?
Minus negative 3.
Negative 3. Perfect. All right, so this is linear. Now, just for kicks, let's make the formula for it. Do you guys remember y equals mx plus b? All right, so the m is what you're adding. So what you guys said, that's negative 3. A negative in there. Can you see that's a negative in there? It's hard to tell. That's a negative. It looks like it. Here, I'll make it. I'll put it right there. There. And then, what was the b value? Do you guys remember what the b value was? It's the y-intercept. It's when x equals 0. That's the y-intercept. So when x equals 0, what's y up here? 2. There you go. So y equals negative 3x plus 2. That's like a flashback from 1215. We did tons of those in 1215. All right, now we're going to look at the same thing, but we're going to figure out how to find an equation for an exponential. Is this exponential? What am I multiplying by each time? I'm multiplying, to get to 16 to 8, I'm multiplying by, no, I'm not doubling it, but you're right, it's a half. Okay, so I'm going to call this, our book calls these values A values. So I'm multiplying by a half. Here m would be negative 3, here A is 1/2. I'm multiplying by a half to generate that table of values. So just like the linear ones, we need a starting value. So the y-intercept is your starting value. So over here, what's our starting value? It's always like at time t equals 0, or at an input of 0. That's your starting value. So what are we starting at over here? What are we starting at? When my input 0, what's my output?
16.
16. So those are the two pieces of information you need to make an exponential. You need a starting value, which I have denoted here, and an A value, which is what you're multiplying by each time. So it would be 16 times what I'm multiplying to generate that table of values to the x. So you have mx plus b burned in your brain. Now we need c times a to the x burned in your brain. So let's put all these together. So we have this exponential function. Okay, a is a positive real number, but it can't be 1, because if it's 1, then it's linear. And c can't be 0, because if it's 0, then again you have this linear concept. Okay, c is called the initial value. It's the starting value when x equals 0, or like when time equals 0. And a is called the base. If a is bigger than 0, no, actually that should be 1. Oh, I take that wrong. Hold on. This should be bigger than 1. Woo, let's get rid of that. If a is bigger than 1, then we have something that's called a growth factor, and you'll understand why in a minute. And if a is stuck between 0 and 1, then you have what's called the decay factor. And you'll understand, whoa, did you just have a chill? That was really weird, Maria. She just like had a mini seizure or something. If a is stuck between 0 and 1, then we have a decay factor. And you'll understand why I say it's a decay factor in a minute. All right, here we go. All right, we just did that. We just found the formula. So now, I gave you 1, 2, 3, 4. So either linear or they're exponential. First determine if it's linear, and then you can find the equation. Then determine if it's not linear. Hopefully it's exponential, unless I screwed up. And then you can find the equation for the exponential. So as a reminder, mx plus b those are the two you have to kind of keep in your back of your brain. It's your y-intercept. Yeah, your starting value is really your y-intercept. And b is the y-intercept, right? They're both considered the starting value. Both y-intercepts. Well, it looks like I only have one that's linear. There's only one that's linear. So whether it's linear or exponential, you still need that y-intercept. All right, what's the first one? Linear or exponential? Are we multiplying by a constant or adding a constant? You're dividing, right, which is technically multiplying, right? So if you're dividing by 2, you're really multiplying by a half. Does that make sense? Okay, so my starting value, what's my y-intercept? 80. What am I multiplying by? What did we say? 1/2, and that's always to the x power. So that one's exponential. What about g? Is that linear or exponential? It's exponential. We're multiplying by 3 to generate that table. Okay, so what's my starting value? What's my y-intercept? 4. I'm multiplying everything by 3 to generate that table. Getting the idea? I think h is exponential too, right? Are we multiplying by 5? Okay, starting value is 3. I'm multiplying by 5.